So those diagrams that we used to show the different set operations, those are called Venn diagrams. And now we're going to see some more complicated examples of Venn diagrams and using Venn diagrams to justify some ideas about some of the set operations. So here we start with a question. Given sets A, B, and C, is it always true that if I do A union B and then take that with union that with C, is that always going to be equal to the union of A together with B union C? So in other words, does order of operation, does the order in which I do the unions matter? In other words, if I first find A union B and then take the union of that with C, is that going to give me the same result as if I first do B union with C and then union A with that? And we're asked to justify the answer with Venn diagrams. So there's going to be a few parts to solving this. So the first thing we're going to want to do is draw a Venn diagram for the left-hand side of the equals sign. Right? We're trying to see if this is equal to this. So we're going to start by drawing the strategy will be to draw a Venn diagram of this, and then we'll draw a Venn diagram of this, and we'll see if they match up. We'll see if they look the same. So we'll start by drawing a Venn diagram for A union B, and then with the union with C. So what we do is first of all we have to set up our sets. So here we're doing with 3 sets. We have A, B, and C, and we have to draw them like this. Why? Because there might be some overlap between A and B. There might be some overlap between A and C. There might be some overlap between C and B. And then there might be some overlap where A, B, and C are all overlapping, right? So we have to account for all various possibilities of overlapping among A, B, and C. So we draw these 3 circles, and those are A, B, and C. And now we want to shade in the part that corresponds to this. Okay, so we start with A union B, right? We start with the parentheses first. So A union B would be this thing shaded in here, right? This is everything that's in A or in B or in both. And then we have to do union C, meaning so now we have to add in everything from C. So we're left with the entire diagram shaded in, all 3 circles completely shaded in. So that's the Venn diagram for A union B, union C. Now, next step, again, we're continuing with this example. Next step is draw the Venn diagram for the other expression. Right? Draw the Venn diagram for this. So we'll start with again our 3 circles. We first do what's in parentheses, so we do B union C, and then we add in A. So we have A union B union C. So we're left with this. Now, if we compare this diagram to the one from before, we see that they're identical. So the conclusion is that A union B union C is equal to A union B union C. Okay, because their diagrams look identical. So we can conclude that they are in fact the same. They are always going to be equal. Now, we can notice here that the parentheses really don't matter, because whether I put the parentheses like this or I put the parentheses like this, they're equal. So we can therefore drop the parentheses and write it like this, just A union B union C. And we can drop the parentheses in this example, since they don't make a difference here. Now, in other examples, parentheses will be very important. So we can't just assume that they are never important. But in this particular example, we have shown that they don't actually make a difference. Next example, next question. Given sets A, B, and C, is it always true that A intersected with B and then intersected with C? Is that always equal to B intersected with C and then A intersected with that? And we want to justify the answer with Venn diagrams. So now we're going to try drawing a Venn diagram for this left-hand side, right? A intersected with B and then intersected with C. However, if you try doing it in one step, in one diagram, it's not going to be so easy, because it's a little tricky to think about it. So what I like to do is to do it in 2 steps and draw 2 separate diagrams. Okay, so the first step is as follows. First, I want to draw A intersected with B. Why do I want to do that first? Because that's in parentheses, so I have to do that first. So first I want to draw A intersected with B. So I have this, my 3 circles, and now I want to do A intersected with B. Okay, that's A intersected with B. Now I need to take this and draw the intersection of this left-hand diagram, this diagram that I just made, the intersection of that with C. So where is that going to be? So in other words, where is the place where C intersects with the shaded part of this diagram? Okay, so the shaded part of this diagram is in this area and in this area. Only this middle area intersects with C. This bottom area doesn't have anything to do with C. Okay, so this is the drawing of A intersected with B and then intersected with C. We get this. We end up with this drawing where only the center is shaded in. Now, so that's the drawing for the left-hand side here, right? Again, this is not the final. This is not the correct. Sorry, this drawing here was not the correct drawing for this, right? It was not ultimately the correct drawing for this. However, we needed it to help us along the way. If we would have just tried drawing this to start with, it would have gotten pretty confusing. Okay, so now again, so we drew the Venn diagram for this. Now we have to do this. Okay, so that's the next slide. Draw a Venn diagram for A intersected with the intersection of B and C. So once again, we're going to do this in 2 steps. So we're first going to draw B intersected with C, which is this. And then we need to find the intersection of A with B intersected with C. So if we take a look at this shaded area, which part does A intersect with? See, it's just the middle area. Now, if we compare the drawings on this slide with the drawings on the previous slide, right, specifically the one on the right, we see that this drawing here on the right is equivalent to this drawing here on the right. Conclusion is that the intersection of A and B intersected with C is always equal to A intersected with the intersection of B and C. And because the parentheses, as we see in this example, don't make a difference, we can drop them in this particular example. Next example, given sets A, B, and C, is it always true that A union B then intersected with C? Is that always equal to A union the intersection of B and C? Okay, so it's the same A union B intersected with C, but the difference is where we put the parentheses. Do we put the parentheses around A union B, or do we put the parentheses around B intersected with C? We might think that they're the same. We might think that they're different. Let's try to justify the answer with Venn diagrams. So we'll start by drawing a Venn diagram for the left-hand side of the equals sign, right? So we want to draw a Venn diagram for A union B and then intersected with C. So once again, we'll do it in 2 steps. So first we'll draw A union B, which is this. Then we need to draw A union B intersected with C. So we need to find which part or parts of the diagram does A union B intersect with C. And the answer is this shaded area. Okay, these 3 parts, which make up a shaded area. So that's the drawing for A union B intersected with C. Now we want to do the diagram for A union B intersected with C. So we first do what's in parentheses. That's B intersected with C. So that's this, B intersected with C. And then we want to find the union of A with B intersected with C, which is this. Now, if we compare this drawing here on the right with this one here on the right, we see that they're not the same. Okay. Conclusion, in general, A union B intersected with C is not equal to A union B intersected with C. And we see in this example, the parentheses matter because in both sides on both sides here we have A union B, and then intersected with C. The only difference is which one we do first. Do we do union first, or do we do intersection first? And it makes a big difference. So in this example, the parentheses matter. So are parentheses optional when you have an expression involving union and intersection? So the rules are, if an expression involving sets uses only union or only intersection, then the parentheses are optional. If an expression involving sets uses both union and intersection, then parentheses are essential. And without them, you might not know the meaning of the expression, right? The meaning of the expression could be determined by the parentheses.